Show that the equation cos theta minus 4 divided by sine theta minus 4 sine theta divided by 5 cos theta minus 2 equals 0 may be expressed as 9 cos squared theta minus 22 cos theta plus 4 equals 0. This means that we want to rearrange the first expression so that it looks like the second expression. If we look at the first expression, it has fractions and it also has a sine theta and a cos theta. But then if you look at the expression we want to rearrange it into, it has no fractions and all the trigonometric terms are cos theta. So what we should be doing to turn the first expression into the second expression is to get rid of all the fractions and to turn all the sine thetas into cos thetas. We can get rid of the fraction or get rid of the denominator by multiplying both sides by the denominator. Once we got rid of all the fractions, we still have a sine theta term that we need to turn into a cos theta. And from the formula sheet, we have the identity that says that cos squared theta plus sine squared theta equals 1. If we rearrange this for sine squared theta equals 1 minus cos squared theta, which we can use to replace the sine squared theta in our expression. After multiplying out the brackets and simplifying the terms, we get 9 cos squared theta minus 22 cos theta plus 4 equals 0, which is what we were trying to get. Part 2. Hence solve the equation cos theta minus 4 over sine theta minus 4 sine theta over 5 cos theta minus 2 equals 0 for theta from 0 to 360 degrees. In these questions, they like to lead you to your answer. So sometimes, if the first part of the question asks you to prove an identity or express this expression in a different way, you can guess that when you solve the expression, you have to use the other version of the expression, which is 9 cos squared theta minus 22 cos theta plus 4 equals 0. Cos squared theta is just the square of cos theta. This means that we have an expression that looks like a quadratic, so we can solve it like a quadratic. If you let x equals cos theta, this turns into 9x squared minus 22x plus 4 equals 0. In the normal circumstances, we can usually factorize the quadratic, but in this case, we can't, and whenever we can't factorize a quadratic, we use the quadratic formula. After using the quadratic formula, we get x equals 11 plus and minus the square root of 85 divided by 9. Our x is equal to cos theta, so this equals cos theta. So therefore, we have two answers for cos theta, 11 plus the square root of 85 over 9 and 11 minus the square root of 85 over 9. 11 plus the square root of 85 over 9 is approximately equal to 2.247. If cos theta equals 2.247, there is no solution for theta because cos theta only goes between minus 1 to 1. 11 minus square root of 85 over 9, however, is between minus 1 and 1. Therefore, we can find the value of theta by doing inverse cos. Every time we do inverse sine, inverse cos, or inverse tan, there could also be other values for theta depending on the range of theta the question gives you. The range of theta for this question is from 0 to 360 degrees, so we need to search for the other values of theta that give the same cos value. We can do this by using the cosine graph. The value corresponding to 78 degrees is around here. If you draw a straight line to the right, it crosses the graph again at this point. Therefore, the other angle that gives the same cos value should be over here. The cosine graph is symmetrical around 180 degrees. So if the first angle is 78 from 0, then the other angle must be around 78 from 360 degrees. So our other theta value is equal to 360 minus 78.59. We can also use the unit circle to find the other angle corresponding to the same cos value. 78 degrees is in the first quadrant. The other quadrant that will give the same cos value is over here. Therefore, the other angle corresponding to the same cos value must be 360 minus 78.59 and therefore gives the exact same answer as using the cosine graph.